First of all, a mesh was generated by the conditions specified in the following table. With these conditions, 212,000 cells were obtained for the mesh. The following physics models were used: gravity, which was important in order to reflect the effect of gravity on the blender; cell quality remediation, which, due to the meshing, helps improve the results; implicit unsteady, which is important to define because the model is resolving for a transient state; Eulerian multiphase, which is important to define the phases that are going to be present in the blender, including properties like density and viscosity; segregated flow, which lowers computational time. Finally, multiphase interaction was used to define the superficial tension of both water and honey and helped characterize the interface between both liquids and air.
The Reynolds number obtained for water was 1,794, which means it is a turbulent flow. Therefore, the following physics models were used: the K-omega turbulence and the turbulent suppression models. The K-omega turbulence is a two-equation system model. The variable K represents the kinetic energy of the turbulence, and the omega variable represents the dissipation rate of the turbulence. The turbulent suppression is a model used to solve a turbulent condition. This copies the effect of the transition by eliminating the turbulence in the specified region.
The Reynolds number obtained for honey was 35.37, which reflects a transition flow. For this transition flow, it was necessary to use a specific physical model for honey, which was K-omega turbulence, which is specific for transition flow, and gamma transition, which gives some equations that permit to solve the K-omega model for transition flow. With this model, it was obtained a better answer for knowing the behavior of our flow, which in this case is honey.
It can be seen for both simulations that the liquid forms a vortex as it happens in reality, with which it can be observed that a star also serves to model the agitation of a fluid independent of its regime, turbulent, transition, and laminar. However, some incongruent results were found. It can be observed that honey develops more vortex than water, and this may be due to the fact that to simulate the agitation of a high viscosity liquid, a better meshing and pre-processing is needed to obtain reliable results. Instead, water is a fluid that the program works easily, and it can be seen that the results obtained are pertinent. It must be taken into account that the physical simulation time is very short, 0.1 seconds, and it is not possible to see the vortex fully develop in water.
Finally, it can be seen that the geometry of the blender allows the formation of a vortex, which permits to conclude that, in contrast to a Russian turbine, this blender does not possess buffers.